Good afternoon, Barcelona. So I'm here to speak to you about the state of 2D in Unity. And before I begin, I would like to know who's in the room. So hold your hands up, high and proud, if you are an artist. Artists always a little lower, high and proud. There we go. There we go. There's some secret artists. Fantastic. And any coders in the room? Does anyone still write code? Okay. Cool. Fantastic. Any designers? That could be artists as well, right? Okay, cool. Same as well. A few low hands, kind of a designer. Okay, nice. Cool. And any technical artists? Tech artists. There you go. My people. Awesome. All right. So we're going to talk about integrating 3D, new physics, and more. And I am Russ Camel, Product Strategy Architect for 2D at Unity. And of course, I couldn't be doing any of this without these wonderful people. So it's my great honor to work with these wonderful folks in the 2D team at Unity. So we are a team of comprising engineers, right? Coders, designers, product people, and tech writers as well to produce all the documentation. And our mission is to make Unity the best 2D engine in the world to power the amazing 2D games that you create. Now, the sample that we will feature quite a lot in this talk was part of the content production machine of the tech content marketing team. So they create samples and long-form ebooks. Maybe you're familiar with some of those, like the 2D ebook, and video tutorials to help devs like yourselves skill up in a wide range of topics, from coding to art to production. So check out their content on the URL here, or by checking out Unity's YouTube session, where you'll find a lot of really cool stuff that has been produced over the years. Some of the folks closely involved in this project are Edu, who is sitting right here with us, from the tech content team, who's been working with the 2D team closely for many, many years. Guillaume, who coded many of the tutorials that you can see on the Learn platform and other demos. And Osson, who is a pro VFX artist exploring everything that VFX Graph can bring to 2D. And our latest 2D sample and many of the other 2D samples would not have been possible without the work of Jarek Majewski. And Jarek is a multidisciplinary technical artist, 2D, 3D designer, and independent game creator. He runs his own studio, Mindjar Design, and he is a solo developer creating his game Ultimate Action Hero, which you can add to your wish list now. Cool. So let's take a look at what we will be exploring today. We're going to look at new improvements to 2D rendering that makes it easier to integrate 3D in your 2D games. You might have caught some of that in the keynote earlier today. We're going to take a deeper look at the new, powerful, and flexible low-level 2D physics, APIs. We're going to discover the new Sprite Atlas analyzer and why you need it in your life today. We're going to break down the improvements that we've been making to 2D animation performance. We're going to introduce the new 2D sample in a little bit more detail. And we're going to take a sneak peek, because I always like to do that, into the future developments in 2D. Okay, so let's begin by talking about integrating 3D in your 2D games. So let's consider why you might use 3D, right? 3D objects in your 2D worlds. Now, a lot of it comes down to art direction and the style you're going for, as well as your specific gameplay needs, perhaps a certain level of detail that you need. So we can see excellent examples here of combining 2D and 3D in side-scrollers like Super Mario RPG, and games that use an isometric perspective like Super Mario Run, both by Nintendo. There's also a significant benefit to production efficiency, especially with characters. So if you're using 3D, this can mean less work when you're trying to rotate or position characters for different angles, if you think about like isometric games, and less need for swapping out all of those 2D sprite parts, like different hand positions. You can also more easily create cutscenes using the same character assets and take advantage of reusable animations. And finally, consider large enemy bosses, right? When you want to move a very large 3D object, it can sometimes be more performant than rendering a very large and detailed sprite sequence. And by default, 3D models are sorted by z-axis, which is generally not how we want to organize things in a 2D project. We want to generally avoid clipping between 3D objects and sprites as well. And that's where the sort 3D as 2D comes in. So by adding a sorting group to a 3D object and checking the sort 3D as 2D option, it essentially flattens the 3D model and makes it behave just like another sprite, solving all of those tricky sorting issues. Now, in Unity 6.3, projects that use the 2D renderer in URP make it easy for you to add mesh renderer or skin mesh renderers to a 2D environment, such that it lights correctly and renders seamlessly with other 2D objects. You can use the default Mesh 2D lit default material or the Mesh 2D unlit default, like we do at the top, where a simple color texture has been assigned to the material and it gets immediately visually integrated into our 2D game. Or, because we want to keep it flexible, you can make your own shader graph shader that outputs a sprite unlit, sprite lit, or sprite custom lit material, making sure to enable the sort 3D as 2D compatible checkbox. This allows you to add more advanced effects. So if we look at the one down here, like the Fresnel light shader that we have on the character. So for 3D objects that you want to render as 2D, the materials can have the same maps as any other 2D lit object, namely a base map, a normal map, and a mask map. Okay. Let's watch a brief video of how 3D was integrated in the new 2D sample. So here, sorting. Let's look at the 3D character as it moves in between tile maps or 3D objects that are laid out in the environment as collectibles. A more subtle effect you may have seen is the use of Z-writing to enable effects like depth of field. I'll just pause it briefly here. Oops. So if we look at this scene briefly, you can see that there is a depth of field effect between the front and the back. So that is done by enabling the use of Z-writing to enable effects like this, right? So the depth of field. That way you can blur your backgrounds and your foregrounds, and you bring focus to the character. Now we also see masking. So sprite masks are used to reveal the cave interior, for example. And at the end, we can see that the 3D object is only visible inside the sprite mask. So I'll go back to the video briefly and just show you that end part one more time. So at the end, the character comes into this mask. And that's a 3D character that has been masked by a sprite mask, by a 2D sprite mask. Okay, cool. Now we can also see that there's shader graph shaders that have been used on the character. And these are used for sprites or 3D objects as well as particles. There's also lighting that has been happening here. So the 3D character is being lit by the 2D lights. And this was the another shader graph example here. And then down here, we can see that the camera sorting layer texture is being used to create reflective water. And finally, all of the VFX graph effects that we see in this scene have been used to produce everything from simple effects all the way to some more advanced visual effects on the GPU. So one of the more important considerations when you're trying to render this way is to think about which method you want to use for rendering order. So you have two basic ways, right? You want to use the z-axis as the main criteria for sorting any object. This is like a cardboard theater, right? So it's like a puppet show with cardboard props as the environment, giving the feeling of depth as the character can move between them. Or, as we see on the right there, do you want to bring 3D objects into your 2D world, which is already sorted in layers, right? So if you want to do that, then the 3D object needs to be sorted by sorting layer and order in layer, like any other 2D elements. So for this, we would need to enable the sort 3D as 2D in the sorting group. So let's explore each of these a little bit. So if we look at this, one of the benefits of arranging objects on the z-axis is that you get this natural parallax effect, right? So as the character moves, the different layers can move at different speeds. And we see that in the sample earlier. This is especially noticeable, of course, with a perspective camera, because you get the effect in a more pronounced way. Now, we can also take advantage of enabling Z-write in the 2D materials. So here we can see an even stronger example of the depth of field effect that we were talking about earlier. By writing to the depth buffer like this, we will be able to use post-processing effects that need to read from it, which creates distinct focus and blurs to the appropriate parts of the scene. And you can make your own depth effects based in shader graph by using the scene depth node. So, cool. Now, if you want your 3D objects to be lit by 2D lights, use a sorting group component on the 3D objects, and you will need to set the right sorting layer. That's really important to remember, to get the right 2D lights to affect your 3D object. You basically need to have this cohesive strategy for sorting layers and Z positioning. For example, you might want to make sure that your 3D objects, where the Z is closer to the camera, also have a sorting layer that matches this position. We use this technique in our sample that you can check out at the booth if you want to see what we did to resolve this. Okay, so the second technique, as we said earlier, bringing 3D objects into your 2D world. Since your project is already primarily a 2D project, everything is in the same Z position and sorted by sorting layers. So sorting 3D as 2D makes it super easy to flatten 3D objects so we can render them by 2D sorting rules, just like sprites. It also means that it's easier to avoid clipping, right? Where one object cuts into another object because they are contained in the same 3D position, since it's sorted by sorting layers and order in layer. So for example, we know this from a previous demo. This is Happy Harvest. Everything here is 2D, right? Even though some of the effects look 3D, this has been very well crafted. It is entirely 2D. And we're going to bring in the 3D character from our new sample, and all we did was turn on the sort 3D as 2D. So if we look here, so that's really quite interesting. Everything is 2D except for that bunny, right? He's 3D. Cool. Now, the benefits of working this way are that you are less constrained by real-world 3D positioning, right? You can batch your renderers that use the same materials, and most importantly, you can keep using your 2D workflows, and the 3D object essentially becomes a guest in your 2D world. Now, sprite masking was also greatly improved in Unity 6. So with the addition of being able to use any 2D renderer as a mask source, now in Unity 6.3, you can look for the mask interaction on any 3D object, any of the supported 3D renderers, right, which we had earlier, the mesh renderer and the skinned mesh renderer. And then you can mask any 3D object using 2D sprite masks as well. So again, you can find some examples in the demo, and this really unlocks a lot of visual and gameplay possibilities. Greatly enhanced, because now we're combining both of the worlds, 3D and 2D. So finally, a little addition we made fairly recently is if you want to change that mask interaction at runtime, for example, right? We've added a new API, so it's much easier to create these kind of gameplay effects. So like this bunny, at first, he is visible outside the mask, and as soon as he hits a trigger, he's visible inside the mask, and that is done through a runtime API. Cool. So these are all the ways that we've made it a little simpler for you to bring 3D into your 2D projects. Okay, let's switch gears a bit. So 2D physics. In Unity 6.3, we have low-level 2D physics based on the latest Box2D v3. This thing, I want to talk about it a little bit. It's very interesting. It's a whole simulation that comes together and then forms an image exactly the same way every time. So all of the end result of all of the simulation is that everything just ends up landing in exactly the same place. And this is an example of some of the work that we're doing to improve the deterministic output of the physics simulations. Now, this new API also empowers developers to have direct access to the new physics system. So just to be clear, it's a new physics system. There's a low-level API. There are no high-level components. We'll talk more about that later. Now, this new 2D physics system delivers both speed and flexibility, and you can leverage it to create physics objects directly in your scene, or you can use it to design your own custom components. Okay. So let's take a look at how the physics objects are structured. So there are all these different things, and at the very top level, we have a physics world. So you can have multiple physics worlds. We'll talk about this later. Now, the physics world represents an isolated simulation container. A world can contain physics bodies inside it, representing a position and rotation in the world, and some additional behaviors. And each physics body can have multiple physics shapes, representing an area relative to a physics body. Now, physics shapes, they get their geometry data from predefined geometry types. So circle, capsule, segment, polygon, for example. And physics bodies can also contain something called physics chains. This is a dedicated physics shape that represents a chain of line segments that are connected together to produce a continuous surface. And finally, physics joint, which is the base of a set of joints available to constrain pairs of physics bodies together. So the low-level physics API uses a powerful multi-threaded physics system. This is the one that's built on Box2D version 3, and it is highly parallelized out of the box, which means that it will scale up to 64 cores if you have that many cores available on a device. So the example up there, for example, that comes from the sandbox demo, and that's something that I'll give you a link to later. Each one of those boxes is actually an isolated physics simulation. They don't know about each other, right? There is no communication between them. So this is useful when you don't need to simulate the entire game. You just want to simulate in buckets. Right? Cool. Now, there's support for all of these multiple independent and isolated worlds, and those are simulated in parallel, and these are fully configurable. A really cool part of it is that the majority of the API can be called in a C# job, away from the main thread. So this is how we get a lot of the multi-threaded advantages. And since all of the API is struct-based, all object structs are just handles, are struct handles. Therefore, if you wanted to, you could use them to work with Unity native containers for dots, for example. Now, it also features a rich query system that works with C# jobs too. So that's also going to add to the advantages of using this system. Okay. Now, what's really interesting is that all of this works independent of game objects and components. Like I said earlier, we're not shipping any new game objects, any new components with this API today. But it has there's a lot of support in the API to work with them. So if you're simulating in your physics and you want to then write to transform or transform planes, you can do that. It supports unlimited number of bodies, shapes, or joints per world, and you can use batch operations to create and destroy. And one of my personal favorite features here is that it supports multiple 2D transform planes. So for many years, you've been constrained to the XY plane if you're trying to do 2D physics in Unity, but maybe you want to use the XZ or the ZY plane. So simulating 2D physics on the XZ plane, or the floor plane, is especially useful as it enables a common use case in 3D games, where the visuals are 3D, but really all of the gameplay is just calculated on the floor plane. So you can use a 2D physics solution for your 3D games. And finally, it includes a full debug drawing system, both in editor, that works both in editor, like this, and also works in runtime in development player builds. So all of the voids that we see here, this is all drawn using the new debug drawing system. Now, it's really important to understand that the current physics 2D components, the ones that you've used for years, that you know and love, nothing about those have changed. These are not under the hood being changed to the new physics system. The low-level physics APIs are completely isolated from these existing physics components. Why is this important? So you've been running your games for years, you've expected a certain kind of performance, you want to be able to upgrade your project to Unity 6.3, and you want your behavior to remain exactly the same, right? You don't want any difference in your solvers, you don't want any difference in your behaviors. So this is very, very important. Okay, so we saw a lot of cool stuff earlier, and I want to give you the resources to play with those. So if you've seen them and you want to try them out yourself, we did do a discussions post about this, but if you haven't yet accessed it, here's a link to get the project for the Physics 2D low-level sandbox. This is a really, really good project, I should say. It demonstrates all of the various features of the new API, and Melvin, who works on this, he's going to be adding more and more examples to this regularly, so it's definitely a repo that you want. And in the same repo, but this is a link to a different part of it, there is a primer project. So this is if you want to learn about how the APIs work. There's a series of very simple scenes where we show you how to make a world, how to make your own physics objects, how to make your own joints, things like that. So this, again, very useful. I would scan that and check it out. Cool. Sprite Atlases. Sprite Atlases are probably one of my favorite subjects because of how much they impact the performance of 2D games. And optimizing and managing Sprite Atlases is vital for large projects, right? So if you've got a large project, you've got a lot of sprites, You absolutely want to have some kind of atlasing. And this is especially important when you're running on resource-limited mobile platforms, right? So you want to make sure that you have smooth game performance. And as we all know, performant games retain users, right? So the problem is Sprite Atlases are often misused and can introduce performance issues instead of making your games run better. So knowing about this, in 6.3, we've introduced the Sprite Atlas Analyzer tool. Now, this tool finds inefficiencies in atlasing by providing built-in reports to identify common issues that are found in productions. So we worked with studios, we worked with our partners in the Unity Studio Productions and their partners in different studios, and we found all the different ways that people run into problems with Sprite Atlases. So you can use then this information that comes out of this to inform your Sprite Atlas optimization efforts. Now, it also works, I really like that it works really well with the project view. So if you select any of the Sprite Atlases or sprites that you see in the Sprite Atlas Analyzer, it will also select the corresponding asset in the project view. And it displays the inspector for that asset, therefore, and this allows you to then quickly investigate or act on any of the detected issues. Okay, so let's look at some of the things that tend to go wrong, and then what does the report look like so that you can do something about it. Okay, so the first one is very standard. It is the kind of the top level report, and it's just called All Sprite Atlases, right? So this report shows all of the Sprite Atlases that are available in the project. Contains the data of the sprite associated with those Sprite Atlases, the sprites that are inside it, that are packed in it. And then this data can be used to make decisions on how to optimize that Sprite Atlas. So we can see you can get everything from number of sprites, total memory, area, what packing mode did you use, what's the texture format. This is very important if you need to do some optimizing. But now let's actually zoom in on some of the reports. Okay, so this was a common one. I must have heard this question maybe hundreds of times. So what about source textures that have compression? So we have a report for that. So this one, what it does is it lists all of the source textures that have a compression setting on them. And then they have been added to a Sprite Atlas. And then the Sprite Atlas has been compressed. So when the source texture is compressed and the Sprite Atlas is also compressed, then the user is going to experience a texture quality degradation, right? So anytime you find something like this, you know that the sprite was packed in a compressed format. You can see here there's a few compressed formats there. So what you want to do, select the sprite. Here in the project view, it shows up, and you turn off the compression, right? So then you can find that problem, and then your visual quality is going to go up. So use this to avoid double compression. Atlas page count. This is an interesting one. So very often we see a lot of studios, they'll just pack a lot of sprites into an atlas. Fingers crossed everything's going to be fine, right? Because now it's in an atlas. Problem is, if you get overflow, right? Sometimes it packs and packs and packs, and then there's more sprites than can fit in one page. So if we look over here, we can see that this set of sprites has produced 9 pages, right? Okay, so why is this a problem? Because then you get unpredictable rendering batches, right? Because it's going to try and render things from your Sprite Atlas, but it's going to be calling different pages, right? So you don't want that. So anytime you find a Sprite Atlas that has multiple pages like this, and the report will show it up, like here we have a Sprite Atlas called Tiny Swords, and it has 9 pages. You probably want to bring that down to 1. There's usually no strong use case for a base map atlas that has more than 1 page. And then you want to think about your packing strategy a little bit, right? So maybe you want all of the yellow castle parts in one group and then all of the red ones in another group. So you're not just bouncing around between the atlases, and you can bring it down to one. Cool. Texture space wastage. So this is, again, very cool. It's, again, often the case, you pack everything into an atlas, great, but what if the atlas is not actually doing a good job, right? So each of those sprites doesn't really take up much space in that atlas, and then there's a lot of wasted space. So this whole atlas still gets loaded into memory, and it's just taking up space in memory. Now, of course, you may not want to split the atlas because you're trying to, get some batching going on. So you use this to optimize to the trade-off between memory usage and batching. And then finally here we have sprite count. Sorry, not finally. So again, another common thing that we find in projects is one sprite atlases, right? So you have a sprite and it's packed and it's all by itself in an atlas. So this introduces unnecessary overhead, right? So you're just rendering an atlas for no reason. You're making an atlas for no reason. So anytime you find an atlas with just one thing in it, maybe it could be doing more work, right? It shouldn't just be atlasing a single sprite. Or that sprite can go and join some other sprite somewhere else. Cool. And this one's a little more subtle, but when you're using secondary textures, like maybe your sprites have an associated normal map or an associated mask, you want to make sure that all of the atlases have the same kind of consistent secondary textures. So when this happens, we get a list, when we use this report, I should say, we get a list of all of the atlases that have different secondary texture counts, and then we can identify what the problem is. So I ran this on some of our samples, and I found that there was still some stuff that could be fixed. And then when we improved it, immediately things are running a lot better. Cool. So that's Sprite Atlases. And the new Sprite Atlas Analyzer in 6.3, very, very useful if you're trying to get that fine trade-off between memory usage and batching. Cool. 2D animation. So 2D bone-based animation is used for a significant portion of 2D animation in mobile games. It's very often found in the most successful mobile games, and so it makes sense for us in Unity 6.3 to have multiple improvements to the performance of 2D bone-based animation. So throughout the 6.x cycle, we tuned that performance. And so I wanted to share with you the different ways that we've been doing that, because it has implications on whether or not you see better performance in your games. So we reduced the redundancy. We refactored the 2D IK system. So now it's got improved multi-threading and runtime efficiency, because that now uses the burst compiler. We improved the 2D shadow calculation, again, by using Unity's job system and burst compiler. And we also implemented caching for deformed sprites. So then that eliminates some of the redundant calculations that we're getting when we're deforming. Now, we also added a specialized code path for single bone sprites. So if you see some of the crystals that are flying around this character, it's just one bone that affects the sprite. So there's no need for it to be treated the way other bones are treated. It can just do a much cheaper deformation. In fact, no deformation by bypassing the entire deformation pipeline. We reduced redundancy in bone data structures. So basically there, the end result is memory overheads are lower and you get faster instantiation and destruction times. And finally, we ensured that deformation calculations only happen when the character moves. Because if it's not moving, why are you deforming every frame? So we've made sure that that only happens when the character moves, when there's a change in the bones. So overall, we found that these enhancements give us a boost of about 10% performance on CPU and very pleasantly 30% performance on GPU deformation. Now, of course, this depends on your systems, your devices, and the workload, but expect a pretty significant performance increase in your 6.3 bone-based characters. And in other news, in the world of 2D animation at Unite, we will be compiling all of the great character animations we have authored over the years, and we want to make them more easily accessible, for example, posting a sample pack on the asset store. So this includes all of the characters of different styles that we have made over the years, and this uses the full range of Unity 2D animation tools and tech. So these characters use everything from, of course, just bog standard 2D animation to sprite libraries, sprite swap, the multi-layered characters that we see at the top that have all been imported with PSD importer, 2D PSD importer. And we're also including characters that use secondary textures designed to work with the 2D lights. And finally, at the bottom, you may see a couple of familiar characters from the past. We've finally made some pixel art A-sprite versions of, that's Unity-chan on the right, and then some of the other characters from that world. Cool, so coming soon. All right. Okay, so that new 2D sample that we saw just now, let's talk a little bit about that. So the new 2D sample, as we saw earlier, it uses new features to integrate 3D and 2D. But as always, with these samples, we like to do a little bit more. We explore a little bit, and we tried some different things. And so when you look at the new 2D sample, you will see several key features. So like we're setting up the atmosphere to look really cool with a specialized fog technique as well as a sky technique. And for custom visuals, we applied shader graphs across the sprite shapes and tile maps. So the tile maps are actually quite interesting. So like the interior of the cave, for example. Level design was also aided by the use of splines. So we've got splines used throughout the level. And that includes using moving platforms for gameplay. We're also using some very interesting object distribution effects to quickly fill up the scenes. Like you can see some of the sunflowers at the back. That is wonderfully a VFX graph effect. And the UI visuals are customized using UI Toolkit shaders. So as always, we like to try to use a lot of the Unity pieces together to try and make the sample. If you haven't already, please come and play Bunny Blitz, which is what we're calling this new demo, at the 2D booth on the expo floor. And as always, this is just the latest in a whole set of 2D samples that we have released over the years. So again, if you haven't tried them, check out Happy Harvest, our farming sim. That's the one down there on the right. Dragon Crashers, which is an idle clicker that uses multi-layered characters with 2D lighting. Lost Crypt, of course, our 2D platformer. And Gem Hunter Match, our Match 3 sample. And we are about to finish a really big update to the 2D ebook, which you can already get from unity.com/howto, alongside all the other technical ebooks. But we are finishing an update to that, so look out for that shortly. And this new 2D ebook will comprise improvements all the way from the older LTSs to Unity 6.3, including many things that we saw today. All right, future glimpses. Who wants to see a little bit of what we're working on? Yeah. Oh, no pressure. Okay, so as always, I like to share a little bit of the work that's happening in the 2D team. Some of this, actually, if you get access to some of the betas, you might be able to see some of it already. But as always, when we do this, we have to put a nice safe harbor statement in front of you. The following is intended for informational purposes only and may not be incorporated into any contract. No purchasing decisions should be made based on the following materials. Unity is not committing to deliver any functionality, features, or code The development, timing, and release of all products, functionality, and features are at the sole discretion of Unity and are subject to change. Okay. So let's look at some APIs to help with packing Sprite Atlases for runtime use cases. So as we saw earlier, Sprite Atlases are a useful tool to optimize rendering batches. But what about scenarios where the sprites you want to atlas together will only be known about at runtime? So procedural and user-generated content comes to mind, right? So we don't know what those are yet. So let's look at this example. Imagine we have two theme packs for our character, Emma, and the player can configure this character to mix and match parts from both packs, right? So I want to use the torso, leggings, boots, weapon, and headphones from the modern theme on the right, but I want to mix it with the green hair, spacesuit, gloves, and glasses from the future theme. So without Sprite Atlases, you would need to draw each of these character parts, right? So let's take a look at it in the frame debugger, and we'll see it's a lot of passes. And even with standard Sprite Atlases, you would need to load up the complete atlas. So you'd need to load up both of those atlases just now, right? What if you had 50 themes or more? What would you do? So what if we could have the best of both worlds, right? So introducing Runtime Sprite Atlas API. This allows you to build Sprite Atlases at runtime once you know what needs to be batched. So I've used this API to build a simple runtime atlas builder for Emma. It's going to collect all of the sprites that are used by the children game objects of the mixed character in the scene and then pack it into an atlas. We're already in play mode, so let's build, and you can see we went from 33 down to 2 draw calls. And because it's at runtime, there is a custom packed Sprite Atlas right there, specific for that character that only exists at runtime. So that covers your procedural and runtime use cases or user-generated content. Cool. Okay. And finally, let's take a look at what we're doing to improve extensibility in the 2D renderer. So when you're making your 2D games, you've shown us that you want tools to extend and customize the 2D rendering process while maintaining project upgradability. Because of this, we've been developing APIs and dedicated 2D injection points for the 2D renderer in the universal rendering pipeline. So let's take a look at an example where we add a pass into one of the new 2D injection points. I'll start by adding a color tint render feature to the active 2D renderer here. Now you can see I can choose an injection point in the 2D rendering pipeline before rendering normals or after rendering normals, or shadows before or after, lights before or after. But I want to choose after rendering sprites. And then I want to use that to tint the whole level green. There we are, we're doing that with an injection point. So next, I want to use another custom render feature, a circular pixelator, to selectively render some of the sorting layers as tiny circles. And if you look here, I can choose the topmost sorting layers that I want to affect. And if I keep moving that to the front, you can see I'm slowly changing the whole game into circles. And finally, of course, you can stack these because these are renderer features in the 2D renderer data. And I can get this kind of monochrome retro look, which kind of looks a bit hashy and like a photocopy here, right? So this enhancement will not only unlock greater creative potential and visual fidelity, but very important, it improves the long-term upgradability and scalability of your projects. Because as you upgrade that, you didn't need to customize the render pipeline in any way, but you were able to customize the rendering output. Cool. So that's some of the stuff we're working at, and we're doing more work in the space of extensibility as well as flexibility while making sure that your projects can always upgrade. Now, if you're, as you are, of course, in person with us at Unite, I wanted to highlight that there are more 2D activities happening at Unite. Tomorrow, we're running a roundtable, 2D games in Unity. If you have not, you can register here and then join. And that'll be tomorrow at Gather Room 1 on this floor, which is over there, from 11:30 to 12:30. And the goal here is really, we want to get together, have a chat, understand the 2D development pain points that you're experiencing today, and then maybe see some of the dreams and hopes that you have for 2D in the future. We're also running a 2D feedback lab. So this is an opportunity to use the Unity editor hands-on at Unite with some of us around you, and then we can see where you are getting snagged on 2D workflows, and you can give us some feedback on what went well and what needs to be improved. So again, another QR code. If you want to register for that, you can just take a photo of that, and then we'll see you at the feedback lab tomorrow. That brings us to the end of my time with you today. It's been a blast. Thank you so much. If you had any questions about the features or demos that you saw today, and you want to speak more with me about 2D, we can have a chat outside after this talk, or you can come and find me at the 2D booth at the expo. But as always, keep making awesome 2D games in Unity. Thank you.